For our next scenario, we're going to be looking at how we start adding in renewable energy into our system. So we'll be looking at is meeting interconnection requirements that might be necessary to satisfy the utility that we're interfacing with, make sure that they're comfortable with the additional technology that we're adding in. Often utilities will want to make sure that these distributed energy resources are not disrupting grid operations, that there's not often a reverse power flow. Zero export is often a requirement that you'll see, where they want to make sure that any excess energy that's being produced by your facility is not flowing back to the grid, creating capacity issues or operational issues or even safety issues for that grid operation. So the wave controller can help manage the system within those constraints while still making best use of any available production from those renewable assets that you've invested in. So for this scenario, we're going to be kind of looking at that point of common coupling, that PCC. We'll be adding in those PV assets, and we'll be looking at how we can make best use of those. So we'll switch back to Don to take a look at what that system will look like. Great. All right, so once again, we've got that primary load for the system being fed from the grid. In this scenario, we're going to be looking at the export limiting control. So we'll go ahead and get that started. And then we'll take a look at the trend screen for this control in the wave interface. And we can see some key limits that we've set up here. So the red line up at the top, that's actually at the zero active power limit. So that's our zero export requirement from the utility. We want to make sure that we're never in violation of that, so we don't have any trouble with our utility. And to help us do that, we've set up a control preferred target, which is the teal line there, which is kind of got a nice safety margin below our hard limit, where we're going to be controlling the system below that. It gives us a little bit of room in case there's an overshoot or something unexpected happens. We can still maintain the system below that hard limit. And finally, at the bottom of the screen, we have our reference meters. This will be the point of common coupling and the active power flow there. So right now we're importing about 100 kW of power. So what Don's going to do is we're going to go ahead and use our emulator to ramp up the PV available in the system. So the sun's coming up and our PV system will start producing some power. And as that power becomes available, we'll see that we'll stop using the grid power. We'll use that locally produced energy to the extent possible to be able to meet our energy needs. So we can see that come up, stabilizing there, using that available power. And now as the sun continues to come up, more PV becomes available, our PV production may exceed the current load that we have. And so we'll see that as that available production comes up, we'll kind of start heading towards that limit. But again, because we want to make sure we're meeting those requirements from the utility, we're actually going to curtail the system to stay below that limit, the PV production in the system, so that we stay, a nice margin below that limit, and that we're, no danger of violating that. So we'll use as much as we can to meet our load, but we're also going to make sure that we're not violating that limit here. So we'll curtail that production.